Welcome back to my channel. In today's video, I will show how to reduce a complex trigonometric equation into a simplest solvable question by means of factoring out the common term. Also, I'll be using this video to explain the use of a quadrant diagram to write out solutions of any trig question. But before we go into the question itself, this is the formulas that we have to take note of. The first one is cos A plus cos B to give 2 cos A plus B over 2 cos A minus B over 2. This is the sum to the product identities. Sum to the product identities. The second one is cos into x plus or minus y to give cos x cos y minus plus sine x sine y. So that is the second one, and that one is the sum and difference formula of sine and cosine. The third one is going to be cos into bracket minus theta, which is going to give us cos theta. This one is an even identity. But now, before we go into that, let me just let you know about this question, that this question is very trickish. Why is it very trickish? The reason I say it's very trickish is that we are asked to solve for x from 0 to 180 degrees. And the meaning of that is that we are going to say 0 degrees is less or equals to x, and x is less or equals to 180 degrees. It means that 0 degrees will be less than x, and x, whatever we guess as our solution, must be less than 180 degrees. The reason I say it's tricky is that normally we will be asked to solve for 0 less or equal to x, and x is less or equal to 360 degrees. But we have to pay much attention on this. Now go back to the question. In going back to the question, which we have cos 6x plus cos 4x plus cos 2x, what are we going to do? Are we going to say that we want to expand 6x, we want to expand cos 6x, or we want to expand cos 4x, or we want to expand cos 2x? There is no time for us. We have limited time to solve this in case you are in exam hall. So what do? What we do here is to look at a way to factorize this expression. To factorize this expression out, if we factorize it, then we'll be able to streamline this complex equation. So let's go into it. I looked at this, that all these coefficients of x, they are all even. We have 6x, we have 4x and 2x, they are even. So if we try this way, what do? If we say that we want to get 6, 4, and 2 in the way of addition based on this formula, if we pick this, that 6 and 4, if we say 6 plus 4 divided by 2, that will give us 5, right? Yeah, that will give us 5. And also, if we say 6 minus 4 divided by 2, that will give us 1. That is first case. Another case is if we say 6 plus 2, I'm picking from the coefficient of x that we have. We have 6, we have 4, and we have 2. Now, I'm just trying to do trial and error, but it's not really trial and error. We're going to see what we're trying to do now. 6 plus 2 divided by 2, that will give 8 divided by 2 to give 4. 6 minus 2 divided by 2, that will be 6 minus 2, 4 divided by 2, that will give 2. That's another option. Another option is if we say 4 plus 2 divided by 2, that will be 6 divided by 2 to give 3. And if we say 4 minus 2 divided by 2, we give 1. We saw that from the coefficient of x in the equation, we have 6, 4, 2 to be even. But from these options that we have here, we have this to be odd, we have this to be even, we have this to be odd. I'd rather go with the one that has the even numbers. And if we put that into this first formula, let's see what we're going to arrive with. If we put that into this first formula, in that case, we are going to say let a to be equal to 6x and b to be equal to 2x. Now, I'm working with the one in the middle. I already left out the first one and the last one because they're odd numbers. So I'm working with the one in the middle, which is even number. So we represent a to be 6x, b to be 2x. If we put that into that formula, we're going to have cos 6x plus cos 2x, which will give us 2 cos 6x plus 2x divided by 2 cos 6x minus 2x divided by 2. In that way, we're going to arrive into 2 cos 6x plus 2x, we give 8x, divided by 2, we give 4x. Cos 6x minus 2x, we give 4x, divided by 2, we give 2x. So now, we are arrived into here. But what we see now is that we are going to have two terms. From this equation, we have cos 6x, cos 4x, cos 2x. And in the formula, the one we derive here, we have cos 4x also. That means that the equation cos 6x plus cos 4x plus cos 2x equal to 0 can be factorized out. How do we do that? Say cos 4x plus cos 2x plus cos 6x will equal 0. So if you put this together, this is the same as this. Now, if we now put what we have here into here, we're going to be left with cos 4x plus everything here, 2 cos 4x cos 2x equal 0. So now it will be easier for us because we have already reduced the complex trig equation into the simplest solvable question for us. So now we can factorize because we have this and this common. We can factorize this out. But we should know about this. If we have a, b equal 0, that means that from these two quantities, this means that a is either 0 or b equal 0. This is what this quantity is telling us. If you have these two quantities equal to 0, either a is 0 or b is 0. That is that. In that way, if we now use these two quantities to look at this, let's factorize this out first. So if you factorize this out, we're going to have cos 4x into bracket 1 plus 2 cos 2x will equal 0. This is what we're going to have if we factorize out this. Because if you open this, we have cos 4x plus 2 cos 4x cos 2x. So now, if we now use this quantity that says a times b equal to 0, we imply that it's either a equal to 0 or b equal to 0. So the same thing here, if we use this a, b equal 0, that means that cos 4x is either cos 4x equals 0 or 1 plus 2x equal 0. So we're going to use that to open up that after we have factorized the question, the expression in the equation. Permit me to open this. We're going to have cos 4x into bracket 1 plus 2 cos 2x equal 0. So now we can then say cos 4x equals 0, or 1 plus 2 cos 2x equals 0. So we're going to solve this. We have already factorized. Now we're going to solve this. How do we solve this? We're looking for the value of x, not for the value of 4x. So in that way, we can take the inverse. Let's say this is case 1. Case 1 says that cos 4x equals 0. And let's take this as case 2. Case 2 says that 1 plus 2 cos 2x equals 0. So if we have done that, that means that we're looking for the value of x, not for 4x. So we can take the cos inverse of 0. So 4x now is going to give us cos inverse of 0. That's going to give us cos inverse of 0. So 4x now, and the cos inverse of 0 is going to give us 90 degrees. 90 degrees. If you use your calculator, the cos inverse of 0 is going to give 90 degrees. But still, we still want to find the value of x, not 4x. So we divide both sides by 4. 4x divided by 4. 90 divided by 4. So x here will be equal to 22.5 degrees. That is in case 1. What about case 2? Case 2 says that 1 plus 2x cos 1 plus 2 cos 2x equals 0. So in that way, what we need is to collect the like term, take 1 into the other side. How do you do that? If you minus 1 here and you minus 1 here, because you're going to minus 1 to both sides, that means we have not done anything to it. So if we do that, 1 here minus 1 will give us 2 cos 2x. We equal to 0 minus 1 will give us minus 1. So we still have 2 cos here, and we don't need this 2 here. What we do is to divide both sides by 2. So we have cos 2x divided by minus 1 over 2. That's minus half. Here also we only need x, but we are having 2x here. So we have 2x, then we take the cos inverse of minus 1 over 2. So we have 2x equal cos inverse of minus 1 over 2. Right. And if we do that, we're going to have the cos inverse of minus 1 over 2 is going to give us 120 degrees. But we need x. We have to divide both sides by 2. Divide this by 2. We're going to have x equal 60 degrees. So if we look at this, that means that in the solution, we have that x equal 22.5 degrees in one case. And in another case, we have x equal 60 degrees. But that is not the end of the solution. But before we move on, please, if you have not subscribed to my channel, please kindly subscribe to my channel, watch my videos, and share, like. Thank you very much. Okay, back to the question. Since we have x equal 22.5 degrees and x equals 60 degrees, but we are asked in the question that we should solve for s from 0 to 180 degrees. In that way, this will push us into using the quadrant diagram to solve for all the values of x. So I'm going to draw out the quadrant This is the quadrant diagram. So the quadrant means 1 over 4. It means 1 over 4. So, and we're going to employ this acronym CAST. CAST is the acronym CAST. That means that we have CAST. The meaning of that is that this is cosine, and this means all positive. All of them are positive. Here means only cosine is positive. Only cosine is positive. Here means all sine, tangent, cosine, they are all positive here. Then this one says only the sine is positive. Only the sine is positive. This one is only cosine is positive. Here, all of them are positive. Then in this third quadrant, this is the first quadrant. This is the second quadrant. This is the third quadrant. And this is the fourth quadrant. In the third quadrant, it says that only the tangent is positive. Fine. Fourth, second, on the second, only the sine is positive. So in that way, this is the formula we normally use. Here is going to give you theta, and the second quadrant is going to give you 180 minus theta. The third quadrant is going to give you 180 plus theta, and the fourth quadrant is going to give you 360 minus theta. So if you have this question will be totally solved. But don't forget that we are dealing from 0 to 180 degrees. And what are we dealing with? We are dealing with cosine. And we know that cosine is only on the fourth quadrant. The cosine, under cosine is on the first and the fourth quadrant. Note that the first and the first quadrant, that is where we can find cosine. The first and the fourth quadrant, that is where you can find cosine. We are dealing with cosine question. That means that the case 1 now, in our case 1, we already have that x equal 22.5 degrees. And in case 1, cos can only be in the first quadrant or the fourth quadrant, but the fourth quadrant is not included. So 180 degrees is on, okay, let me put this like this. The first quadrant is going to be under 90 degrees. The second quadrant is going to be under 180 degrees. The third quadrant is going to be under 270 degrees. The fourth quadrant is going to be under 360 degrees. Fine. And now we are dealing from 0 to 180. That means we are going to consider the first and the second quadrant. We have already considered the first quadrant. X there is equal 22.5 degrees. So if you consider the second quadrant, cosine there will be negative. So cosine there will be negative, but we're still going to go ahead with it. If we have 180 degrees minus theta, that means we're going to have 180 minus 22.5 degrees, and that is going to give us 157.5 degrees. 157.5 degrees. That means that on case 1, x is going to be 22.5 degrees and 157.5 degrees. So let's go into the case 2. Under case 2, we already know also that cosine is also in the first and the fourth quadrant, but based on the condition that we have been given that x is less than or equal to 180 degrees, that means we're going to be restricted into second quadrant. So we know that in the first quadrant, x is equal to 60 degrees. So in the second quadrant, we have 180 minus theta, and that is going to give us 180 degrees minus 60 degrees, and that will give us 120 degrees. That will give us 120 degrees. On the case 2, x equal to 60 degrees and 120 degrees. So if you put them together, that all the solutions of x now, x will be 22.5 degrees, it will be 60 degrees, it will be 120 degrees, and 157.5 degrees. So this is the solution inclusively when 0 is less or equal to x and x is less or equal to 180 degrees. Okay, again, having done this, we can also show that these are correct. We can also show that these are correct. How do we check that these are correct? Permit me to move this over. This is a very trickish and very interesting question. So we have that in the first case, we have that x equal to 22.5 degrees and 157.5 degrees. If we try and let our x to be, if we check the value of cos 225 using your calculator, if you check the value of cos 225 using your calculator, you're going to have 0.9238. And also, if you check for 157.5 degrees, that is going to give you minus 0.9238. But this is very important. Whatever you get from both of them should have the same value. You might be thinking, why do we then have minus here and we have plus here? But don't forget this identity that says that if you have cos into minus theta, this is the same thing as cos theta. That means that therefore minus 0.9238 is the same thing as 0.9238 under cosine angle is the same. So there's no difference between the two. If you put them inside the calculator, you're going to have the same. And based on this identity, that has been proven. So what about the second one? The second one, to check for the second case in which we have that x equal 60 and we have s equal 120 degrees. So if you put cos 60 degree, it is going to give you 0.5, and cos 120 degrees is going to give you minus 0.5. So the same rule here, that cos of minus theta is the same thing as cos theta. That means that they are the same. This is the same, this is the same, and this is the same. Thank you very much for listening to the video. I would see you in the next one. Thank you. Bye.